So now our next point is heat equation in one dimension. So if you consider ut, which is equal to alpha square uxx, that's our normal heat equation. So let us consider this u of x comma t, that let it be a function in the form of delta x into beta t. That means delta x is some equation in terms of x and beta t is an equation in terms of t, and let this be a solution of this heat equation, given heat equation. So now ut is nothing but, if this is u of xt, then you have to derivate this equation with respect to t. So as delta x is an equation in x, you can keep it as constant into beta t. So t is variable, so we can have beta dash t. Similarly, ux is nothing but derivating with uxt with respect to x. So this will be delta dash x into beta t as it is. So again taking the derivative with respect to x, you'll get delta double dash of x into beta t. Okay, so now substituting all these values in this equation, given heat equation, you will get ut as delta x into beta dash t equals to alpha square delta double dash of x into beta t. Okay, so now dividing both sides by delta x and beta t, you will get, so delta x will get cancelled, so you'll be left with beta dash t upon beta t equals to alpha square delta double dash x as it is, and beta t will get cancelled and you'll be left with delta x. So let this ratio be equal to some a. Okay, now a is a constant, so a has two two options, whether it will be positive or negative. So if it's positive, then it will be in form of p square, where it is a positive constant, or else it will be in the form of minus p square, where it will be in a form of negative constant. Okay, so now if you consider this as beta dash t upon beta t equals to p square, then solving this, you'll get beta dash t equals to p square beta t. Taking p square beta t to one side, you'll get beta dash t minus p square beta t equals to 0. Okay, so this is the equation you got. Now beta dash t is nothing but derivative of beta t with respect to t, so you can write it as d by dt of beta t equals to p square beta t. So value of d beta by beta, so beta equals to p square dt. So I have just rearranged this. Instead of beta t, I have written beta. You can write it in any way. Now you have to integrate both the sides. So integrating both the side, you'll get, it is 1 upon beta t dt d beta t. So just you will have 1 upon beta t is nothing but a natural log of beta is equal to p square. Now dt is nothing but just 1 dt, so it is into t plus some constant of integration. As it as LHS is in form of natural log, we have to keep RHS in the form of natural log. So we have written ln of c1, which is constant of integration. So from this you'll get beta is equal to c1 e raised to p square t. So I have just removed ln, so taking exponential form, it will be in this form. As we had taken this beta dash t upon beta t equals to a, and we had solved this, now we will take alpha square delta double dash x upon delta x, and we will solve the next part. So now consider alpha square delta double dash of x upon delta x equals to p square. So solving this, you'll get alpha square delta double dash x minus p square delta x equals to 0. So instead of writing delta x delta double dash x, we can simply write delta. So solving this, dividing alpha square, will get delta double dash minus delta p square as it is upon alpha square equals to 0. So now we'll get this as d square minus p square upon alpha square equals to 0. So it is in the form of this. So writing this, you'll get p square equals to, so solving this, you will get d square, which is equal to p square upon alpha square, and taking square root, you will get d equals to plus or minus p upon alpha. So now if we got the value of d, so delta x will be equal to, so the general formula for solving ordinary differential equation was a e raised to dx and plus beta e raised to minus dx. So you'll get AE, value of D is P upon alpha x plus beta e raised to minus P alpha x. So now u of x comma t, which was our initial equation, which was in terms of beta t and some delta x t. So u of x comma t was equation in terms of delta x and beta t. So we have already calculated value of delta x and beta t. So substituting its value, so delta x is nothing but a into e raised to p by alpha x plus beta into e raised to minus p upon alpha x into e raised to p square t. Okay. So now taking e raised to minus p square alpha square t outside, you will get e raised to minus p square alpha square t outside, you will get a into, so this is our heat equation in one dimensional. It is ut equals to alpha square uxx. So now what we are going to do is, you have to state ut in terms of the ith and jth coordinate or kth component of ui. So it is ui k plus 1 minus ui k upon delta t, which is equal to again ui k plus 1 minus ui k. Now what is the value of delta t? So if you observe, then this is your ith axis, this is your kth axis, and if you plot a domain or a field in this, on this plane, ik plane, then you'll get the difference between the ith coordinates, that is delta x is nothing but k, and this is nothing but delta t, so this is p axis. So difference between two consecutive terms is nothing but l. So we'll just substitute the value of delta t as l. Now similarly, value of uxx is nothing but ui k y plus 1 k minus 2 ui k plus ui minus 1 k upon h square. So substituting both this value in this above equation, you will get, so it is ui k plus 1 minus ui k upon L equals to alpha square ui plus 1 k minus 2 ui k plus ui minus 1 k. Okay, so upon h square. So solving this, you have to get, so transferring L to that side, you'll get ui k plus 1 minus ui k equals to L alpha square upon h square into ui plus 1 k minus 2 ui k plus ui minus 1 k. Okay, so now we can substitute, as all these three are constants, we can just substitute it as lambda. So from this you'll get uik plus 1 equals to, transferring this uik to the right hand side, you'll get uik, and this is lambda, so plus lambda into ui plus 1k minus 2uik plus ui minus 1k. So now as you have uik and uik common over here, you can consider this as uik. If you take common, then we have 1 minus 2 alpha, 2 lambda inside the bracket, and the rest is nothing but lambda into ui plus 1k plus ui minus 1k. So I have to just take together this uik terms, and from this you can get common as 1 minus 2 lambda, and then rest as same as it is. So this is known as explicit formula, and this equation is valid for certain condition, and that is the condition is on the value of lambda. So if lambda is in between 0 and half, then this condition is valid or equation is valid, and it is called the stability condition for the explicit formula. So this is the stability condition. Now if we set at the extreme point, that is lambda equals to half, then in the equation we obtain as uik plus 1 equals to half into uik plus 1 plus ui minus 1k. Okay, so this is the value after substituting lambda equals to half. So you can observe that lambda equals to half, then this 2 will get cancelled, so you will be left with just 2 uik, and here half, so half uik plus 1 plus uik minus 1 as it is, and after converting uik you will get 1 minus 1 is 0, so this term will get eliminated, so you will be left with this term or this equation. Now this equation is known as Bender-Smith recurrence formula. So this is Bender-Smith recurrence formula. You need to use this formula to solve for the equations. So you have to just remember the substitution for ut, uxx, and substituting the value of ut and uxx in the heat equation. You can solve this. Just replace all the constants, 3 constant by lambda, and then solving for this you can get the condition for lambda, that is 0 less than or equal to lambda less than or equal to half, and we have to substitute the extreme value for lambda, that is half, and you'll get the Bender-Smith recurrence formula. Now if we replace uxx by the average of its finite difference approximation, and it is on the kth and ik plus 1th time level, so we obtain, so see. So as we had our heat equation, which was ut equals to alpha square uxx. So now ut was already been taken as ui k plus 1 minus ui k upon L. Now for the next method or next recurrence formula, we have to substitute uxx as 1 upon 2 ui plus 1k minus 2 uik plus ui minus 1k upon h square plus ui plus 1k plus 1 minus 2 uik plus 1 plus ui minus 1k plus 1 upon h square. So just substitute, instead of ux's we had substituted earlier something different, so now we need to substitute this. So after substitution you will get ut equals to ui k plus 1 minus ui k. So this is value of ut upon L. So this is ut, which is equal to alpha square. Now 2h square we can take it out common, so 2h square into this entire bracket as it is. So after solving this entire bracket, you will get again uik plus 1 equals to, now again you have to push that L to the other side and uik to the right hand side, so you will get uik plus L x alpha square upon 2x square can be substituted again as lambda, so upon 2 into, now the value of this after solving, so you get it as ui plus 1k minus 2uik plus ui minus 1k plus ui plus 1k plus 1 minus 2ui k plus 1 plus ui minus 1 k plus 1. So this new formula is known as Crank-Nicolson formula, and this is known as Crank-Nicolson formula. So it is stable for every condition. So for any lambda, you can take any lambda and you'll get a stable condition for this formula, Crank-Nicolson formula. So as that was our explicit function, this is known as implicit function, and Bender-Smith formula was explicit and this was an implicit formula for solving the system of equation. So finally, after solving this entire thing, you will get minus lambda ui minus 1 k plus 1 plus 2 plus 2 lambda ui k plus 1 minus lambda ui plus 1 k plus 1 equals to lambda ui minus 1 k plus 2 into 2 minus 2 lambda uk ui k plus lambda ui plus 1 k. So if you observe, then on the left hand side we have three unknowns, right? So now these are the three unknowns which you have, and for this we know the values of each of them. So this is a Crank-Nicolson formula, and it is implicit formula, and it is convergent for all the finite values of lambda. So you can take any value of lambda, it will be a convergent formula, and if there are n internal points on r-axis, then above equation gives n simultaneous equations for n unknowns. So this is the formula for solving system of equations. So if you are given a domain and you have n internal points, after for drawing the domain, if you have n internal points and if there are n internal points on y-axis, and you'll get n simultaneous equations for n unknowns.